Type number 2, limits are not provided. So to solve examples of this type, we should study the different coordinate systems in 3 dimensions. Start with the Cartesian coordinate system. So it consists of 3 mutually perpendicular lines known as ax, y and z axis. So these are the ax, y, z axis. Their intersection point is origin. Then x is distance of the point P from YOZ plane. YOZ plane is written as x equal to 0 plane. Then y is the distance of point from ZOX plane, that is y equal to 0 plane. And z is the distance of point P from the XY plane, that is z equal to 0 plane. So this x equal to 0, y equal to 0, z equal to 0 planes are known as coordinate planes since they are obtained using the coordinate axis therefore. Next, spherical polar coordinate system. See what is done. So start with the Cartesian coordinate system consisting of x, y and z axis. Their intersection point is known as origin. Then consider a point P of x, y, z in a space. From point P, draw a perpendicular to XOY plane, that is z equal to 0 plane. So that will meet the XOY plane in a point M. Since point M is on z equal to 0 plane, z coordinate is 0. So the coordinates of M are x, y and 0. Join the point M to the origin. The angle MOX is known as phi. The angle made by OP with the positive direction of z axis is known as theta, and the distance of point P from the origin is denoted by r. So this r, theta, phi are known as spherical polar coordinates. So spherical polar coordinates are r, theta, phi. R is the distance of point P from the origin and it is given by root of x square plus y square plus z square. Theta is angle made by OP with the positive direction of z axis. While finding theta, consider z axis only since we are considering angle made by OP with the z axis only. Phi is angle MOX. While finding phi, we have to consider x and y axis only. That is, we don't have to think about the z axis. See, the relation between Cartesian and spherical coordinates is like this: x equal to r sin theta cos phi, y equal to r sin theta sin phi, z equal to r cos theta. Whereas dx dy dz equal to r square sin theta dr d theta d phi. This r square sin theta is Jacobian of ax, y, z with respect to r, theta, phi. Next is cylindrical coordinates. Again consider Cartesian coordinate system consisting of x, y, z axis. Then we have point P in the space whose coordinates are x, y, z. From the point P, draw perpendicular to the XOY plane that will meet XY plane in a point M whose coordinates are x, y and 0. Join the point M to the origin. The angle MOX is phi. Distance OM is known as rho, and rho is the radius of cylinder, radius of circle. Then distance PM by distance formula is Z, and that is the height of cylinder. So rho is distance OM, radius of the cylinder. Phi is the angle MOX, Z is the Z coordinate. Now the relation between cylindrical coordinates and Cartesian coordinates are x equal to rho cos phi, y equal to rho sin phi, and z is z only. Dx dy dz equal to rho d phi dz. Now we have to understand a very important point: limits. So consider sphere x square plus y square plus z square equal to a square. Sphere having center at origin and radius is a. So here the limits are r is the radius and radius is a, therefore r equal to 0 to a. Theta equal to 0 to pi since there is no restriction on the set. Phi equal to 0 to 2 pi since there is no restriction on values of x and y. That is, we can consider all the positive as well as negative values of x, y, z therefore. Now understand the next part. Consider a hemisphere. X square plus y square plus z square equal to a square. Z is greater than or equal to 0. Now r is same 0 to a. There is change in a theta. Theta equal to 0 to pi by 2 only since z is positive only. Phi is 0 to 2 pi, no restriction on x and y therefore. Next, consider a sphere in positive octant. Okay, that is x square plus y square plus z square equal to a square. X greater than or equal to 0, y greater than or equal to 0, z greater than or equal to 0. So r equal to 0 to a, theta equal to 0 to pi by 2. Since z is greater than or equal to 0, therefore phi is 0 to pi by 2 since both x and y are greater than or equal to 0 there. Next, consider a cylinder x square plus y square equal to a square circle. Where the circle lies? So two different circles are there. One lies on z equal to 0 plane and another lies on z equal to h plane. And join these two circles to get the cylinder. So limits of z are z equal to 0 to h, which is height of the cylinder. Phi equal to rho equal to 0 to a, that is radius of the cylinder. Phi equal to 0 to 2 pi, there is no restriction on x and y there. Next, tetrahedron. So a surface bounded by 4 planes, right? 3 of them are the coordinate planes and one more plane, say x plus y plus z equal to a, is known as tetrahedron. So the planes x equal to 0, y equal to 0, z equal to 0 and x plus y plus z equal to a form the tetrahedron, and the limits are z equal to 0 to find value of z from the x plus y plus z equal to a. So z equal to a minus x minus y. Now since z is removed, we have x equal to 0, y equal to 0 and x plus y equal to a. From here find the limits of y equal to 0 to y equal to a minus x. Now y also is removed, therefore x equal to 0 and x equal to a. Therefore x equal to 0 and x equal to a are the limits of x.